video information and contact details, so you can visit the startups who are here today, but also the one who pitched yesterday and the day before. So yeah, if you have any technical issue, you can also reach me and I will be happy to help.
Thank you, Julia. And so now it is time to introduce 4 of the 12 startups that were selected as part of season 2 of LH Accelerator, specifically on this topic of decarbonization and the circular economy. The 4 companies we will hear from today are Carbonova, Terra Innova, Agora, and Alta Road. After we've finished this round of, you will see very rapid presentations. They're 4 minutes, so the idea is really to give you a sense of what their company does and to entice you to join them in the breakout rooms later on. But once we're done with this rapid round of presentations, we'll go back to Q&A, and after that, we will part for the breakout rooms. So if we are good to go, I am thrilled to welcome our first company of the day, Carbonova, represented by its CEO, Mina Zarabian. Welcome, Mina.
Hello. Can you hear me well?
Yes, we can.
Okay, perfect. I'm going to tell you the story about us creating carbon solution. Do you know that every year the world adds more than 50 billion tons greenhouse gases to the atmosphere? This is the outcome of linear economy model that says take, use, and waste. On the contrary, circular economy looks at waste and pollution as our new untapped resources. Circular economy paves the road toward net zero emission. Next one. In the last few years, many companies have put serious efforts in reducing their greenhouse gases. Kudos to LafargeHolcim and more than 1,000 other companies that join net zero emission by 2040 based on science-based technologies. Carbonova is here offering a solution that help you reach the target in a cash positive way. Hello, everyone. My name is Mina Zarabian. I am CEO and co-founder of Carbonova, a company dedicated to create a solution for carbon. Our solution, next one, please, utilizes greenhouse gases. More specifically, carbon dioxide and methane goes to our reactor. It combines with waste heat, and it produces carbon nanofibers. Carbon nanofiber in a simple form is like a premium carbon black. Next one, please. That goes to everyday life. Anything that you see around, it has a color of black. It most likely has some sort of carbon in it. Carbon goes to plastic to make it stronger, greener, lighter, and cheaper. It has a global demand of nearly 16 million tons and a market valuation of $20 billion. Next one, please. During LH Accelerator, we had 3 important achievements. First, expanding our product profile. When we started the LH Accelerator, we were only able to produce solid product. Working with experts of LH Accelerator, we developed water-based stable ink that can easily be added to cement formula. Solid powder was hindering our capability of adding it to cement formula, but now it makes it easier and safer to be added to cement formula. Plus, it opens market for us in coating and inks. Moreover, it paves the road. We proved the application for smart concrete. When we started LH Accelerator, we understood that our product can modify the electrical conductivity of cement for smart concrete applications. Having the benchmark of graphite and carbon black, we were assuming 40 to 50% loading ratio is required to modify the electrical conductivity. To our surprise, we understood that only 0.5% addition can enhance the electrical conductivity significantly. To be clear, that was 100 times better performance. And 3, and probably the most important, was modifying our revenue model and business model. We started the LH Accelerator with quite modest revenue model of $50 million. And working with LH team, we expanded to over $240 million only from one cement plant. You may ask how. In this business model, Carbonova is integrated into cement plant. It utilizes carbon dioxide that is captured in the cement plant. It combines it with waste heat that is available in cement plant, and then use methane or natural gas procured and produce carbon nanofibers that goes to the existing market of carbon black. Remember, it was 16 million tons, and part of it goes back to concrete for modifying the properties of mechanical strength and electrical conductivity. Next one, please. We are very grateful for the opportunity to work with LH and Sika, and we are looking forward to continue our co-development project on 3 important aspects. Working together in developing market strategy for current users of carbon black, tires, rubbers, and plastics. Further product development for building materials, we identify very interesting applications with Sika and Lafarge in supercapacitor concretes, electrostatic discharging flooring, and we would be happy to continue working on those. And 3 is the conceptual design of how Carbonova can be integrated into LH cement plant. And with saying that, we believe that we can imagine building cities out of greenhouse gases. Thank you very much.
Thank you, Mina. If there are any questions for Mina, please put them on the chat and we'll go back to them during the Q&A session. And you can, of course, join her in the Carbonova Innovator room. But for now, I'm thrilled to welcome Nathaniel Baumal, who is the CEO of Terra Innova. Welcome, Nathaniel.
Hi, everybody. Hello. So I am Nathaniel Baumal. I am the founder of Terra Innova. I am a construction engineer, and I worked for 10 years in public works. And for 10 years, I really had big problems because of soil waste management, which is also called excavated soil. So do you know what an excavated soil is? Next slide, please. It's what you will get when you dig an underground. Sorry, I think it's the wrong presentation. I will share my screen. Okay. Do you see it well?
We see your presenter screen.
Okay, so it's the wrong one. Okay, back again. So an excavated soil, it's what you will get when you dig an underground, and it represents 160 million tons a year, and a cost of $13 per inhabitant of our planet. So the deposit is very gigantic, and in half of the cases, we don't know what to do with this material, and not only we don't know what to do with it, but we have to pay to just dispose of it. And so a lot of people in the construction industry are looking for a solution, but they stay looking within the industry construction. And very few people look out the side of our agriculture, and yet agriculture also has its problems. Intensive farming generates big damages, big environmental damages, sorry. So what does Terra Innova propose? We propose to create a bridge between the construction and agroecology. So first by recreating hedges and embankments, which is sources of biodiversity and which makes possible to create obstacles to the flow of water, to the wind and to the sun. Then by restoring soils on plots that have become uncultivated or that have lost their soil because of erosion. And finally, we propose to make amendments in order to improve the fertility of existing soils. So doing this way, soil waste can provide a sustainable transformation of the agrosystems, and all our solutions lead to a more resilient society. So what is our economic model? today 1 cubic meter costs our customer $15, which is composed of $7 for the transportation and $8 for the discharge. So how can we lower the price by around 25% and reach a $10 fee? First, by reduced transportation to a maximum of $5 fee. Then we need $3 for the implement of the material. And then for that, we reach a $2 fee for Terra Innova. So what did we do with Lafarge Holcim? We worked with the Agneo team, which is an LH brand dedicated to circular economy. And we worked on 3 use cases. The first one was how to reuse fines coming from quarries, which is coming from the aggregate washing. LH got this problem in a lot of French sites. And for what concerned this case, 800,000 cubic meters are stored near Lyon, which represents around 300 Olympic swimming pools. And this material could be used for agriculture. So we analyzed this material and defined a strategy for the reuse. Then we tested different modalities in our grow room and approached farmers and landscapers in the sector to offer them our products. We also worked on another construction waste, which is the concrete fines from batching plants. And we proceeded as the same as before. And finally, we were able to start working on sites located near Rennes and near Bordeaux on the reuse of soil waste to produce fertile substrates. The objective for Terra Innova is to rely on LH logistical assets and to improve the quality of the substrates offered to our customers. And for LH, the objective was to be able to expand its range of products resulting from the reuse of waste. Thank you for hearing.
Thank you very much, Nathaniel. I'll try to jump right over. All right. For our next speaker, we're thrilled to welcome Christina Ginch from Agora. Christina, are you with us?
Yes.
All right. Take it away.
So, hello, everybody. Reaching net zero by 2030 is a newly announced commitment by Lafarge Holcim. So let's see if Agora technology can contribute to reaching this target. I'm Christina Genge. I'm co-founder and CEO of Agora Energy. We are an electrochemical company from Vancouver, Canada, developing breakthrough advanced materials and technologies for CO2 utilizations. So cement manufacturing, that is key to creating products and structures, stands out for its staggering CO2 emission that will have to be mitigated, because the net zero simple arithmetic tells us that every ton of CO2 that will be emitted will have to be somehow mitigated. This is net zero. So Agora is in the business of developing technologies that use CO2 as raw material to produce valuable products, some of which can enter back into cement manufacturing. That was ahead a bit of time. So at the core of our technology is a large-scale CO2-based redox flow battery. Unlike other metal batteries, our proprietary battery uses CO2 as active material to exchange electrons. So the big idea is that the capture and purify CO2 emitted during cement manufacturing is used in the battery. When energy is delivered, CO2 is converted while the battery is charging. Click press. So during discharging, like any other battery, electricity is released. This electricity can be used back into the cement operation or sent to the grid. And redox flow batteries like ours are really big, large-scale devices ranging between 5 and hundreds of megawatts. And for our battery, each ton of CO2 utilized leads to 1.6 megawatt hour of electricity being released. A variant of our battery has a secondary, as secondary products, carbonates or bicarbonates that have high value on the commodity market. That is was pointed before. The market are not excessively high at present, however. This process that we are creating here is equivalent to CO2 mineralization, and this is how our technology becomes both highly profitable and carbon negative. Next. So we are a young company. We are currently building larger and larger prototype. We are building between 200 and 5 kilowatts prototype at present, and aim to reach the commercial deployment by 2025 in 2 separate markets, the CO2 space and energy storage space, both growing markets. Next. So during this accelerator, it was important for us to find out what are the needs of the cement industry and what would be the economics for implementing such a battery on site. Next. So that's exactly what we did in this project. We did detailed techno-economical analysis for 2 scenarios. One scenario involved the implementation of a 5 megawatt battery on a cement plant setting. Here we look at using our battery for electricity storage from the grid and explore the potential for revenues from energy arbitrage and peak shavings. The second project involved incorporation of the battery as part of a large consortium in the West Coast 100, where many players come together to co-create a green circular economy. Here we analyze the use of a large 50 megawatts battery for large duration storage from either the grid or a wind farm. We were given very strict requirement and stringent requirement for all 4 cases. And the target was to determine the return of investment, the net installed capital cost, and of course, the revenue. Next. So what we find in our, during the 9-month acceleration is that our energy storage technology promises to be extremely flexible, is suitable for short and long duration storage, as well as for low and high storage capacity. And for a 5 megawatt battery, we got a very high projected net revenue, annual revenue, high return on investment, and extremely low installed capital cost. So the most important finding of our accelerator was that we have a very strong business case for CO2 mitigation in the cement industry. And because our subject is quite detailed, I would welcome you to join the demo session for more detail. So we want to very much to thank our mentors, Lafarge Accelerator, and the valuable coordinators that help us through this project. Thank you.
Thank you very much, Christina, and we're super excited to hear more in the Innovator demo. For our last speaker, I'm really excited to welcome Cécile Villette, who will tell you more about Alto Road. And I'm going to share a
It's okay,
video.
I can share, then in that case, it's easier for me.
I'm there. Oh, there you go. It's the other one. Oh. Go ahead, Cécile. Yeah.
Okay, so hi everyone, I'm Cécile, I'm the CEO of Alto Road. Can you see my screen? Yes. So here what you can see is trucks, and the point is, what kind of questions do you ask yourself when you see trucks on your site? Is this truck overloaded? Does it comply with safety regulation? Do I know how much I'm getting in this delivery? I've got no way to check it. Or even how much waste have we generated when we use this transport? So all these questions that are critical for traceability and optimization, you can address with what we offer, meaning being able to weigh trucks anywhere and in a practical way. So this solution is already available on construction sites. And what we are doing is we are weighing the trucks in a practical way where you cannot do it usually. So here you can see it's a video of a site where we are already deployed. and the truck is getting loaded in a place where there's not so much space. And there's 3 steps. First, the truck is passing over our device and camera, and we collect the information. Second, we collect, with this data, we calculate all the information about the truck itself. And then there's a platform where you're going to be able to trace what has been passing on the site, and specifically we'll be able to trace the waste that Nathaniel mentioned a bit before, so excavated materials, but also concrete or cement. So really our objective and our differentiation is because we've got this device that can be used anywhere to be able to trace material and then recycle them so that they can be then upcycled. For this proposal, we got selected by the LH Accelerator last year, and we collected some feedback during the first sprint. And for us, that was one of the highlights of the LH Accelerator session, and the fact that we had access to all these experts. And those experts told us, we've got waste scales, but they become bottlenecks. Or waiting time can be up to 1 week because of weighing. Or we tried to find this system 5 years ago and we could not find it. Or we made a study to put weight scales everywhere, but we stopped because they were not practical. So the feedback that we received was overwhelmingly positive about the value of our proposition of being able to trace materials anywhere when you need it. This is why we've deployed the system during the LH Accelerator program on 2 sites, one aggregate site and one ready-mix plant, in order to validate first the use cases and the gains that you can get from deploying the system on those sites. And second, validate the robustness. So does it survive on our sites in those very hard conditions? And finally, in terms of precision, what do we get? And can we translate that into an ROI? And the good news is that we received an order for 2 systems to be deployed by the end of the year already. And we are now investigating how to deploy the system in ready-mix plants in France. So if you want to know more about this and how it could work also in geographies, come and discuss with us in the breakout room. So I would like to conclude by saying thank you to the LH Accelerator for this great opportunity. Thanks.
Thank you, Cécile. That sounds super exciting, and can't wait to hear more in the breakout rooms. But before we go to these breakout rooms, I would like to take a few minutes for some Q&A. The chat has been very active during the session, and I want to make sure that we have an opportunity to get to some of those questions. I'll first ask maybe Eric and Aisha if they have any questions or comments on some of the presentations that we've seen today. Eric, anything from you?
No, I don't. I wouldn't have any particular questions that I think are relevant for the full session. But I think all of the projects are very interesting. But I don't have any questions that are for the whole session.
Sounds good. And Aisha, anything from you?
Yes, thank you. Yes, I found the presentation very interesting. And I already posted one question on the chat because for it was Christina presentation. The main goal is to use CO2 capture, and I know the cost of the CO2 capture and the purification is a very bottleneck for the CCS project or CCU project. So I was wondering if the cost of CO2 was taken in account. And also one question for Nathaniel, because it's my regulatory how is it point of view, because Adam, it's a French agency. It's about the use of excavated materials for soil. I was wondering if there is no pollutant contained in these materials that prevent to use in the soil. It was, I think, my two only questions.
Great. Well, thanks, Aisha. Maybe Christina, you want to go first?
Yes, we did take into account the cost of CO2 capture. We took the higher price provided by Lafarge-Holcim mentors. It was at 140 euro. That's $165 per kg and per ton. Sorry, and yes, we in all our calculation we went to the extreme of being very, very conservative and taking the worst case scenario.
And you have some profitability with this very high amount of CO2 of the
Yes.
cost.
Yes.
Very interesting.
Yes.
Okay, thank you.
And Nathaniel?
Yes, thank you for the question. So yes, there is a big stake to check if there is any pollutant in the soil we use in an agricultural area, because this soil is cultivated and it's in contact with water coming from the rain and going to the stream rivers. So we are very precise on checking which kind of pollutants we can have on heavy metals. And I saw another question, so I can answer it also. We are not so interested in the lixivation metals, but more in raw material and how much metals there are in, because we use a very few thickness of soil in our solution.
Thanks for the answer, Nathaniel. Eric, there was another question for you on the chat from Christophe Levy, who asks, so he totally agrees with you on your priority topics of new-gen SCM, filters, digital automation, etc., but asks, according to you, what are the most promising avenues within new-gen SCMs in addition to calcinized clays?
Yeah, so I think the ones that I'm most interested in are the waste. Well, I mean, I think there's plenty of promising avenues, but I think the ones that fit within this framework of a economic feasibility, especially, are often waste-derived SCMs. So that can be through the waste minerals at quarries, or that can be through large-scale industrial waste streams. And I think, yeah, I think if you look at those raw materials and you look around for the chemical components that you need for an SCM, and you look for a very, very, very low cost processing method for those, that is where I think the really interesting and promising avenues for next gen SCM development are going to come from. And I think, you know, if you start to look for natural resources, opening new quarries, you start to get into permitting issues, et cetera, et cetera. But if you look for existing stockpiles or existing production of waste minerals or waste materials from industry, you know, you jump forward several years in the development and the economics of developing around those projects. So that's where I tend to look.
Right. Thanks for the answer, Eric. So I think we'll stop here, but the discussions should continue in the Innovator rooms. This was a very engaged discussion, so thank you all for participating and for putting all your questions in the chat. So here's how the next hour is going to work. Each of the 4 startups will have twice 2 30-minute sessions to get into their innovation and the work that they've completed during the accelerator. So